Okay, so we're going to try to look at how we can write a program about matrix multiplication. So, prerequisites is obviously you know how to work with matrix multiplication. So, essentially, if you know this, if you know how each element, say we have a matrix A of order mn and a matrix B of order np, and they output to a matrix C of order MP, where n is ignored, obviously, n has to be same. Then each element of the C matrix can be written by the following. So now, if you're familiar with this, you can probably skip forward the explanation or me trying to jog your memory about it. Else, you might want to be looking at this. Anyhow, so a useful diagram uh, for understanding how matrix multiplication, how you might visualize it. So, so this is give me a minute. Yeah, this is matrix A. Now, visibly, it has four rows, two columns, so it's of order 4 plus 2. And this is matrix B, visibly two rows and 4 times 3 columns, so it's of order 2 plus 3. Now it's commutable for, it's commutable for multiplication because the number of columns in A is equal to the number of rows in B, so that's fine. And the resultant will be a 4 cross 3 matrix. Now, each element of the resultant matrix C, say this particular element, if we look at this particular element, it is C. It's in the first row and it's in the second column, so C12 and C12 will be given by A of 1 1 multiplied B of 1 2 added by A of 1 2 multiplied by b of 2. And this is just simple this multiplied by this plus this multiplied by this. And okay, we'll do another example. This is on the third row and on the third column, so it's C3 of 3. And then again, similarly, A3 1, B1 3 plus A3 2, B2 3. Again, just multiplying this against this against this. And so now essentially you can go ahead and write this for each and every element, but we won't do it. I'm just doing it for two so that you can see some sort of similarity. Now, what's the similarity we want to observe? It's the fact that, well, this part is the same, and that's obvious since the, what do you call, the row of C is corresponding to the particular row in A. So that's obvious. It should start at 3 and it should remain 3 because we're multiplying that particular row only. So that's obvious. Next is the column of C is corresponding to the column of B, which is again stationary. And that's obvious again because you're not changing the column. So the only thing which is actually changing is the column element of A and the row element of B. Now, interestingly, it's changing by an increment of 1 only. Similarly, here it's starting at 1 and then going to 2. And this is actually the only feature which is to be observed in matrix multiplication to write the code, because essentially we're familiar with making a matrix, means assigning values to a particular matrix. Say I'm given a matrix A, of a particular order, I can easily write a code to accept this matrix values inside it. And I can easily write a code to accept some other matrix values, say b, in another variable. Say this is stored in an array variable a, and this is stored in an array variable b. So both of these things, doing both of these is quite easy. The only hard part possibly was multiplying it and storing it in another C variable. So that part, the trend which is to be seen is the fact that this element, the row element of A and the column element of A and the row element of B are incrementing by one. So now in code, how do we probably perform the same thing is the question. So essentially, by now you should have understood how this formula comes about, and the interesting fact of this one once, as you see here, jumps by one, and ij is staying constant, and then going all the way up to n, where n is the uh, common thing in A and B, which is basically the column element of A, the row element of B. So now that we've understood this feature is the only thing which we had to understand. We can go about trying to code this. Now I've coded this pre-hand, but I'll probably walk you through what I've done step by step. So initially there's nothing worthwhile actually. I just display enter a. I create two variables x and y, and I scan these x and I create a array named a of the required order, and then I prompt the user to enter the elements, and I store the elements in the array a, which is symbolic for means which is storing the values of matrix A. Now this is quite trivial. Hope you got this. You should have. If you haven't, probably pause and try to get that. Next, we repeat the same thing for B, but instead of directly asking for the elements before that, I just create a variable L, and it's just temporarily being created, and uh, it stores the row element of B, and then we create a condition where we check whether the column element of A is equal to the row element of B. If it's not, then matrix multiplication is not possible. So then we're done. Uh, yeah, here probably mm, I'd have to add a return sequence so that the code ends there. And yeah, the code will end here. So that's not interesting. That's not what we want. Anyhow, continuing, we after creating B, side by side I create C. That's okay. That can be done anywhere. And then I prompt for the elements of B, and then I scan elements of B. Now that's all trivial stuff. This is where things actually become interesting. Now here we're trying to store the value of C, means we're trying to compute the value of the matrix multiple C. So now we open loop I, open loop J. Now that's fine. Nothing great there. Nothing interesting there. Now comes the point where the trend means the interesting thing we saw here of these jumping values, like 1 1 is jumping to 2 2. So I can essentially just write Cij, and I can take one element, means one particular thing at a time, say this, and then put it in a loop where I put k and I initialize it to general 1, and then it goes all the way up to n. So that's essentially what we're doing, if you can see in this piece of code right here. And once you've done that, we're actually in business. And then the matrix multiplication is computed. For doing that, we have to initialize c of ij equal to 0, and then we make it in a chain, we loop it, and then we display final elements of c, and we're done. That's about it.